guys, Gian here. Let's talk about self-driving cars. Are they really the promise of the future? According to some accounts, self-driving vehicles are estimated to be a $77 billion market by the year 2035. So the mainstream adoption of this technology is going to have macro effects across our entire economy and disrupt many of the services that we know of today. For example, collision repair shops. Not going to be a thing in 10 years just because of how safe these vehicles actually are. But how do self-driving cars or robo-vehicles actually work? Let's pop the hood. Broadly speaking, there are two primary neural network architectures that form the basis of many of the deep learning algorithms used today, such as convolutional neural networks, CNNs, and recurrent neural networks, RNNs. RNNs are optimized to process sequential or temporal data, such as taking audio files and converting them into text files. CNNs, on the other hand, excel at analyzing and interpreting visual information. So this area of artificial intelligence is known as computer vision. And some of the problems that convolutional neural networks have helped solve are the following: image classification, object detection, object tracking, and anomaly detection. All in all, helping vehicles make sense of its environment and making it what scientists call situationally aware. Advances in computer vision have broad applications across virtually every industry. And if you think about it, what information processing task performed by humans doesn't involve our eyes, our ability to see? Very few. For today's video though, we're going to focus on one application of this technology, robotaxi services, which we can think about in two umbrella groups: transport of goods and transport of people. Transport of people is pretty straightforward, so let's focus on transport of goods, which has a lot of market potential. Some of the use cases: grocery deliveries, food deliveries, medicine and pharmaceuticals, construction materials, general everyday goods. Now, general everyday goods is interesting because it's the one category that every retailer either wants to compete in or is already aggressively competing in. Any company that incorporates robotaxi fleets into their delivery service would gain many advantages, such as reduced labor and operational cost, would be much cheaper to maintain and operate the autonomous vehicles versus human drivers. Operational efficiency and automation, one less thing for a retailer to worry about since the robo-taxis will be almost entirely managed through software and AI. Reduce risk and liabilities. Considering how extremely safe they're going to be on the road, any type of property damage would be virtually non-existent. And last but certainly not least, significant increase in output. Robo-taxi fleets could, in theory, operate 24 hours a day and 365 days a week, which would give any service provider a major competitive advantage. So let's say, hypothetically speaking, that Target decides it's going to invest millions of dollars in acquiring a fleet of robo-vehicles from Tesla to expand their in-store delivery capabilities. Now, one of the reasons I picked Target is because ever since the pandemic in 2020, they've deployed a unique strategy of turning some of their stores into mini fulfillment centers. This is a smart move in my book because they have all their stores in all the right zip codes. So if they can leverage their store locations and integrate automated delivery services, that would set them up in a really good place for the next decade. So what would be some of the challenges that come with adopting this new technology as a major national retailer? Well, there's actually many challenges that would need to get addressed, but I'm going to focus on the ones I believe service design can have a major impact and help a company like Target envision a new service delivery model. First up, software integration. From the retailer enterprise software side, how are they going to provide the robo-vehicle with order details such as shipping address? From the supplier side, ensuring robo-vehicles can communicate live updates to store systems such as when the delivery is complete. Back-end systems to capture vehicle data in a structured way to provide analytics to the retailer, such as metrics, deliveries per mile, things like that. Synchronizing internal systems to auto-generate alerts for the end user, such as when the delivery is complete, as shown in this little infographic here. Fleet management and logistics, designing touch points across time and space for the robo-vehicle in context of the store. How do we map this out? signage, wayfinding, and clearly marked loading area to prevent clash with freight trucks. And making sure it's located as close as possible to the store's stockroom facilities to minimize any type of bottleneck. Employee experience, workflow changes and fulfillment tasks are likely going to happen even though we're removing the human element. Interacting with the robo-vehicles, is there going to be a natural language interface? The ability to monitor and track vehicle location, status, and progress perhaps is going to require the introduction of a business dashboard software. And change management effort to facilitate the smooth adoption of this new robo-vehicle service. Rollout strategy, identifying the relevant stakeholders that are vital to helping enable this new service delivery model. Mapping out all key processes across the service delivery cycle end to end. Applying holistic design approach to ensure readiness at the organizational level. Documentation and knowledge sharing for scalability and future expansion. So speaking of documentation, what might a service blueprint for this look like? So we start with the customer actions as the anchor for this document, mapping out their journey. Pretty straightforward. They're browsing on the app or a website. They go to the cart to check out, and then they make a decision on what they're going to order. They confirm the delivery type, and on and on. Following that, we map out the employee actions. Receiving the notification, some kind of alert, retrieving the item from the stock room or in the store shelf if the quantity is limited, marking it as pending shipment, assigning a route to the robo-vehicle, and then finally loading the vehicle with the actual goods. From the e-commerce website, not going to go into that too much, more or less handling the transaction of the sale. And then beyond that, we have the store systems. This is all enterprise retail software. Receiving the purchase order for the item delivery. Is it in stock? Is it not? That would coordinate with the store's inventory management software, updating the inventory and count for that particular item, transferring those the order details to the Robotaxi. So what about the Robotaxi actions? Although this is an automated piece of technology, it's important that we still outline some of the activities that happen, which in this case are 3 simple steps. The Robotaxi receives an input of the order details and shipping address. They go to pick up the order from the store fulfillment center, and then self-drive to the order destination.
You've got mail.
Thanks for watching. I hope you learned something. I'll catch you next time.